welcome to True Projects. In this video, we are going to explain about the project, which is implementation and analysis of blockchain-based decentralized application, which is DApp for secure sharing of student credentials. Introduction. The main focus of the project is to leverage blockchain technology to enhance the security and accessibility of students' academic credentials. Traditional methods for storing and sharing academic credentials, specifically relying on centralized servers, come with their significant vulnerabilities. These servers can be susceptible to hacking attempts, and when they experience downtime, it can lead to a lack of access to crucial academic documents. This poses a significant problem for student and educational institutions. To overcome the limitations of traditional methods, this project introduces a solution built on blockchain technology. Blockchain is a decentralized system where data is stored in blocks. Each one is linked with the previous one with a unique hash code. This design ensures the integrity and security of the stored data. Blockchain offers several advantages for securing academic credentials, it is immutable, which means once data is recorded, it cannot be altered or deleted. It provides a high level of trust. The cryptographic security mechanisms used in blockchain ensures that data remains confidential and tamper-proof. Additionally, blockchain's transparent nature allows users to verify the authenticity of the documents, enhancing trust in the system. There are many types of blockchains such as Ethereum, Bitcoin, Stellar, Ripple, etc. Each has its unique features, governance models, and target use cases where we are using Ethereum in this project. Ethereum goes beyond just recording transactions. It allows developers to create small computer programs called smart contracts. These smart contracts, without the need for a centralized authority, a legal framework manages tasks like storing and getting evidence. Ethereum's strengths include its ability to create various decentralized applications, which are dApps, and its active community of developers. Objective of the project. The core objective of the project is to bring about a significant transformation in how student academic credentials are managed. Blockchain is used to securely store information about students and companies. This data is maintained in a decentralized manner, enhancing security and accessibility. While blockchain itself may not store images, the project integrates the interplanetary file system to store certificate images, which is IPFS. This hash codes of these images are stored on the blockchain, ensuring data integrity and reducing storage constraints. We aim to utilize SHA-256, which is a cryptographic hash function. SHA-256 is employed to generate unique hash codes for student credentials, such as certificates. These hash codes serve as a secure and efficient means of data encryption and validation. SHA-256 is known for its high level of security, making it suitable for protecting sensitive information. It is particularly useful for verifying data integrity and authenticity, enhancing trust in the system. Requirements of the project are hardware and software. In hardware requirements, we need processor of i5 and above, RAM of 8 GB and above, ROM of 25 GB and above. In software requirements, we need Node.js, Python of 3.7.0 version, Visual Studio Community version. For execution of the project, we have designed few modules in the methodology. The first one is School Login. This module focuses on providing access to educational institutions for managing and verifying student academic credentials using the blockchain-based system. Here we have the sub-modules which are enrolled students. In this section, schools can log in to the application and have the capability to enroll new students. This involves adding new student details to the system, likely including their personal information and academic records. The next one is Upload Certificate Credentials. Schools can upload academic credentials such as certificates onto the system. These credentials are securely stored and associated with the respective students. The next one is Update Certificate. Schools can potentially update or modify existing certificate credentials if needed. This might involve correcting errors or adding additional information. In this, the last one is View Student module. Schools have ability to view the details of enrolled students. This could include personal information, academic records, and uploaded certificates. Coming to the next module, which is Company Login module. Here we have the two modules. The first one is Send Access Request. Companies log into the application and send access requests to specific students. These requests likely involve asking for permission to access the academic credentials of certain students. The next one is Access certificate. After receiving the permission from students, companies can access and view the academic certificates of the student who grant them access. This allows companies to verify their certificates. Student login. The student login module is focused on providing students with secure access to their academic records and facilitating the sharing of their credentials. Here we have the submodules which are view your details, which means students can log into the application and they can view their personal details and academic records that are stored in the system. This provides them with an overview of their own information. The next one is access your certificates. Here students can access and view their own academic certificates and credentials through this section. It allows them to have a digital access to their educational achievements. In this, the last one is view access request. Students can see access requests from companies that want to view their academic credentials. Students have the option to grant or deny these requests, controlling who can access their records. Blockchain integration. The blockchain securely maintains academic credentials, ensuring they remain unchanged, including certificates and educational records. Both students and company data, including user profiles and access permissions, find a home on the blockchain, offering decentralized and verified access. Access control facilitated by smart contracts on the blockchain enables students to manage who can securely access their academic credentials. Certificate images are stored using the interplanetary file system, which is IPFS, with their unique hash codes securely recorded on the blockchain. This combination leverages the strength of both technologies for a robust solution. For execution of the project, first we need to open the code folder which contains source code files. This is the code folder of the project. This is the student credential folder. Inside this folder there are Python code files that are intended to be dynamically loaded into the project code during runtime. This is student credential folder. This folder comprises of a static folder, templates folder and Python code files. In static folder, there are files related to CSS, JavaScript and Bootstrap files. These files contribute to the visual and interactive aspects of the application. Coming to the templates folder, within this folder we will find the HTML pages used throughout the project. It includes pages like index.html, home.html and more, representing various sections of the website. Coming to the Python code files that will be executed during the runtime of the application, supporting its functionality. This is the manage.py file. It is a command line utility that comes with the Django. It provides various commands for managing Django projects, including tasks like running the development server, creating database tables, applying migrations and more. So first we'll open the HelloEth folder. This is the node module folder. This folder contains dependencies or modules needed for our project. So first we'll open this. This is the bin folder. This folder contains executable scripts related to the project dependencies. So we will open this folder. This is the run blockchain.bat file, which is a Windows batch script to start the blockchain. This script will initiate the local Ethereum blockchain for development purpose. So first we'll double click on run blockchain.bat file to start the blockchain. Blockchain will be hosted on the local machine at the address which is the localhost and the port number. So here we need to use the command truffle space migrate. This will compile and deploy smart contract. Truffle is a development framework for Ethereum that simplifies the process of compiling and deploying smart contracts. So now we'll click on enter. After running the migration, we will receive a unique contract address. So this is the unique contract address. This address represents the location of our deployed smart contract on the blockchain. This is the gas used. To execute the Solidity file and compile smart contracts, this is the amount of gas used. So we will minimize this and get back to the main directory. This is the start ipfs.bat file. We have to double click on this to start the IPFS server. IPFS server started running. Now let the server be running. So we will minimize it. Now we'll double click on run server.bat file. Instead of executing the project through command line interface, we have created Windows batch file to execute the project. Now we will double click on it. Django framework will host the application locally at the default address, which is the local host. This is the local host and this is the port number. Now we have to copy this local link provided by the framework and paste it in any browser. I prefer Google Chrome, so I'll paste it in that. So here I will paste the link and at the end I'll type index.html and click on enter. This is the web page created by using the Django framework and this is displayed using the web browser. So here we can see various links which are school login, company login and student login. So first we need to click on school login. As the school has not signed up, so first we need to click on new school sign up here link. So here we have to give all the school related details which are school name and the address of the school, contact number of the school, and the username of the school and the password. Now we will click on sign up. So here we can see that school sign up task is completed. Similarly, we have to do company login also. As the company has not signed up, first we need to click on new company sign up here link. So here we will give the company name, address of the company, contact number of the company, username of the company and the password. Now we'll click on sign up. So here we can see that company sign up task is completed. Now we'll get back to school login link. So here we need to provide the school login credentials, which are the username and the password. And now we'll click on login. So school has logged in successfully. So here we can see various links which are enroll students, upload certificate credential, update certificate, view students and log out. So first we need to click on enroll students to add the student details. So we need to provide all the student details which are student ID and the student name, school details, course name and the joining date of the student. Now we'll click on enroll. So here we can see that new student enrollment task is completed. Now we'll click on upload certificate credential. So here we need to fill all these details to upload the certificate. So first we need to give the student ID, certificate details and the issue date. Now we need to click on choose file to open the certificate. So we'll choose the certificate and click on open. Now we'll click on upload certificate. So here we can see that certificate is saved on IPFS with the hash code saved in blockchain in the hash code. Similarly, student ID, certificate details, issue date also will be stored directly in blockchain, but the certificate first it will be saved in the IPFS and then in the blockchain it will be saved with the hash code. Now we'll click on update certificate. We need to fill all these details if we want to update the certificate. I don't want to update the certificate, so directly I'll click on view students. So here we can see that school name of the student, student ID, student name, school details, course name and joining date. Now we'll log out of the school. Now we'll log in as the company. Here we need to provide the company credentials, which are the username and the password. And now we'll click on login. So the company has logged in successfully. So here we can see various options which are send access request, access certificate, logout. Now we need to click on send access request link to get student details and then we can send access request to them. So here we can see various details of the student which are school name, student ID, student name, school details, course name, joining date and the send access request. So now we have to click here link to send the request to that student. So here we'll click on click here. Here we can see that access request sent to student now, student number 1. So now we will log out as company and log in as student to grant access to the company. Here student, login. So we will click on student login. So here we will give the student ID and click on login. Student has logged in successfully. Here we can see view your details, access your certificate, view access request and log out. So first we'll click on view your details to see all the details of the student. So here student can see his school name and all other details. Now we'll click on access your certificate link. So here we can see student details, which are school name, student ID, certificate details, issue date, file name and the certificate's hash code and the certificate. Now we'll click on view access request. So here we can see student ID and the company name which has sent him the request for access, and the access status is pending, and grant access. So by clicking on the click here, we can grant access to the company. So here we can see that access request granted to the company XYZ. Now we will log out of student and log in as company. Here we have to provide the credentials of the company and the password and click on login. So the company has logged in successfully. Now we need to click on access certificate to see whether the student has given access or not. So here we can see that the student has given his access. Here we can see his details, certificate and the hash code of the certificate. In this way, the blockchain can save student credentials securely in the blockchain. Now we will log out. The project has effectively established a secure and decentralized system for overseeing student academic credentials. Transparent management of access permissions is achieved through blockchain-based smart contracts. This project provides a pragmatic solution to mitigate the risks related to data loss and tampering within academic credential management. In summary, the project demonstrates how blockchain technology has the capacity to transform the storage, sharing, and security of educational records, emphasizing its potential for innovation.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.